This is ChemQuest 36, or gases in moles. The gas constant, PV equals nRT, will remain constant as long as the number of moles of a gas remain unchanged. Anytime you measure a gas, the pressure times the volume divided by the temperature in kelvins will always equal the same number unless the amount of gas in the container changes. Here you are given two tables of experimental data for three different samples of gas, one that contains the same amount of gas and the other that contains a different amount of gas. To prove that PV over T is a constant for the data in table 1 but not a constant for the data in table 2, you take gas A and gas B and you set it equal to each other, which equals 2.5. And when you take gas D and gas E, they do not equal to each other. And this is because the number of moles of gas is not constant in table 2. Which of the following is a constant for table 1 and table 2? And that is the equation PV divided by NT. Using this, you can solve for the ideal gas constant, setting R equals to PV over NT. You plug in gas A, and you get 8.31 kilopascals liters over moles Kelvin, which is your R value for the ideal rate constant. Which of the following equations is considered the ideal gas law? And that is PV equals nRT, or Pivnert. At 215 kilopascals of pressure and a temperature of 318 kelvins, 2.35 moles of a gas has what volume? You use the ideal gas law, R, to calculate V. You use the equation Pivnert, and you set the equation equal to V. You plug in all of your variables, and you get 28.88 liters. What is the temperature of a gas if 4.11 moles of a gas has a pressure of 315 kilopascals and a volume of 12.5 liters? You use the equation Pivnert. You set the equation equal to temperature. You plug in all of your variables, and you get 115.3 kelvins. 23.5 grams of carbon dioxide or gas is at a temperature of 45 degrees Celsius and a pressure of 125 kilopascals. What is the volume of the container? You change the grams to moles, which is 0.0534 moles. You change the temperature to kelvins. You use the equation Pivnert. You set the equation to volume. You plug in all of your variables, and you get 11.3 liters. Molar volume is the volume of 1 mole of a gas. Depending on the temperature and the pressure, a mole of a gas may have different volumes. You can assume that we are talking about 1 mole of gas, so N equals 1. What is the molar volume of oxygen or gas if the gas has a pressure of 120 kilopascals and a temperature of 38 degrees Celsius? Use the ideal gas law with N equals 1 for 1 mole of gas, and you solve for V. You use the equation Pivnert. You set the equation to volume. You convert the temperature to kelvins. You plug in all of your variables to get 21.5 liters. Prove that if two different gases area at the same pressure and temperature, each gas has the same molar volume. Question 9, we used oxygen. In this question, we'll use nitrogen at 120 kilopascals and 38 degrees Celsius. You plug in the same constants, and you get 21.5 liters, which is equal to question 9. What is the molar volume of any gas at STP? At STP, the standard temperature is 273 kelvins, and the standard pressure is 101.325 kilopascals. You use the equation Pivnert. You set the equation equal to volume. You plug in your constants, which gives you 22.4 liters, which is the standard volume. Why do you think all gases have the same molar volume at STP? This is because the molar volume of a gas depends on the temperature and pressure, and not the identity of the gas.